Hello everyone, it's Flight Sergeant Chan. I'll be teaching you the last lesson, or not the last lesson, but my last lesson for this virtual cadet training center. Um, the layers of the atmosphere. This is a meteorology lesson, and we'll be going over basically the 5 layers of the atmosphere. So, the overview, yes. So we'll be covering the different layers of the atmosphere, including the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And we also have an activity for you to do to help you make a little model of the Earth's atmosphere to help you remember if you ever forget. So the first section will be the 5 layers of the atmosphere. We'll be going over the different layers and kind of aspects of what it contains. So the first layer we'll be talking about is the troposphere. The troposphere is the layer that we interact with on a daily basis. It's the lowest layer of the atmosphere, and this layer contains about 75% of the whole atmosphere in mass, and also contains 99% of the water vapor as well. All the weather happens in the troposphere since that's where all the clouds are. But there is no ozone. There is no ozone here, but we do have carbon dioxide. Um, Another unique aspect of the troposphere is that it can trap pollutants within something called the inversion layer, causing smog in urban areas. So an inversion layer is where the hot air sits upon a layer of cold air. You already know that hot air rises and cold air sinks. So there's just like a little area where they don't mix. So if the pollutants from a cold start gets released into cold air, it rises, or like if it's like smog, like not smog, like coal smoke, it rises, and then once it hits the hot air layer, it just sits underneath it, so it causes like a little haze. It's harder to explain in words. I think it'll be easier if you saw something in person. So maybe if you want, you can search up a video if you don't quite understand what I'm talking about. Um, I might also leave a video in the video links of this lesson. And yeah, okay. So another aspect of the troposphere is that it is thicker at the equator than at the poles because of this gravity and the shape of the Earth causing the layer just to be thicker there. Um, and also causes unheating of the surface since there's more heat at the equator. And that heating causes like patterns because the air moves around the Earth like that. And that is the troposphere. And then we are going over the tropopause, which is the boundary between the troposphere and the stratosphere, the next layer. It prevents the 2 layers from mixing together, although sometimes thunderstorms can reach the stratosphere, but that's not normal. Like most of the things most of the clouds often are located in the troposphere, not the tropopause or higher. So, as yeah, that. As well, airplanes just fly above the troposphere since there are no clouds past this boundary. It also could help kind of not fly into like turbulence. That's also a thing that can happen. Um, the height of the tropopause also depends on the temperature of the layer underneath. As a result, the tropopause is higher at the equator as opposed to the poles, which is also partly why it's thick. The troposphere is thicker at the equator because it's just warmer there. Then we're going to talk about the stratosphere, which is the second lowest layer of the atmosphere. There is a lot of ozone in this layer, so much that it actually forms a little ozone layer, ozone shield. I forgot the name. Well, anyways, it forms a layer of the ozone gas, and it can heat up the stratosphere because you absorb the UV radiation from that it's excess coming from outside in space, and air is roughly 1,000 times thinner in the stratosphere than in the troposphere. And once again, commercial planes fly in the lower layer of the stratosphere to avoid turbulence. And due to the tropopause and how it prevents the air from mixing with the stratosphere, the air from the troposphere mixing with the stratosphere, volcanic eruptions, which send gas and other aerosolized particles into the stratosphere, can see it be suspended and sitting there for a very long time. Um, there is also little air convection in the stratosphere since there's not a lot of temperature changes. Everything's pretty still and you can't really mix with the layer underneath. So that's why there's a little movement of the air up there. Then we're going to talk about the stratopause, which is the transition boundary between the stratosphere and the mesosphere. But that's really all I can say about it because it's not too impressive or remarkable. It's just the boundary between the two layers. So we're going to next talk about the mesosphere. So the mesosphere sits just above the stratopause and stratosphere. It is very, very cold. It is only gets colder as altitude increases, and it's like up to 90 degrees, negative 90 degrees Celsius or negative 100 degrees Celsius. Um, the air up there is not dense at all. It it contains like 0.1% of all the mass of the atmosphere. Um, yeah, there are such things as noctilucent clouds sometimes, which form here, which is very odd for cloud formation since most of it is located in the troposphere. But they do happen, and I think it's only located in the poles, really. You can search those up. Those are pretty cool. They also look pretty cool too. Um, more thing is that it's very difficult to study the mesosphere since weather balloons cannot reach that high and satellites orbit above the mesosphere. So we don't actually have many instruments that could help us study the mesosphere. So we don't have too much information really. Most of media let me restart. Most of the meteors which come from space start vaporizing in the mesosphere. So some of the burnt material lingers and as a result, the mesosphere has a higher level of iron and other metal atoms. Then we're going to talk about the mesopause, which is the boundary layer between the mesosphere and thermosphere. It is also the coldest region on Earth, with temperatures as low as negative 1,000 degrees Celsius due to the lack of solar heating and the lack of carbon dioxide radiative cooling, or due to carbon dioxide cooling it. Messed up there a little bit. My bad. Um, then we're going to talk about the thermosphere, which is the fourth layer. The thermosphere is what is considered to be the upper atmosphere. So temperature increases as you go up the thermosphere, actually. So unlike the mesosphere, which is the coldest as you go up, the thermosphere actually gets warmer as you go up. Um, the thermosphere absorbs a lot of high energy radiation coming from the sun, such as X rays and UV rays. The radiation sometimes ionizes the air molecules and creates a layer of ions called the ionosphere, which is pretty cool. Then as well, auroras also occur in the atmosphere. Charged particles from outer space collide with particles in the thermosphere, and light is released from the collisions of the excess energy. So we see them as auroras if you go up north. Then we're going to be talking about the thermopause, which is the transition boundary layer between the thermosphere and exosphere. There's also not much to say about this layer because at this point, at the exosphere, it's really almost space, so it's not too much. It's almost the same as the thermosphere. It's just gonna get warm. And this is gonna be the last pause layer because after the exosphere, there's no such thing as an exopause because we'll talk about it. The exosphere, there is nothing past the exosphere. So, um, at one point, you have a few particles, maybe one in every around 1,000. I won't say actually. One in the statistic was that a particle can go about 1,000 kilometers before they hit another particle. Um, so we can get how little dense, how not dense the part of the exosphere, and then it slowly blends into nothing. So it's just a gradual loss of density. I don't know how I don't remember the word, but I think you understand what I'm trying to say. It has air particles until the point where there are no particles. So it's basically space at that point. And another term is the exobase, which is the lower section of the exosphere. I'm not exactly too sure exactly why it's defined, but that is definitely one of the places with more air particles in the exosphere. That I guess would be definite that you have a layer there. All right. So section 2 is our activity. So I made this. It kind of looks like this, but it looks pretty plain because I didn't add anything on it. So this is just a quick craft to remember the different layers of the atmosphere. I will post a document on the in the folder for this class in the C18 Air Operations channel in the Files tab. Um, it'll help you make, it'll help you remember, and it'll look pretty nice. It looks pretty cool too. I think you agree. I hope you agree. I spent a little bit working on it. It didn't take more than around half an hour. Took a little bit around half an hour. So you can time that, but you can decorate as you like. You can add a meteor in the mesosphere because that's where it burns up. You can add an airplane on the stratosphere. It's a lot of things you can do if you want to customize it. You can even color the layers if you want. It's all up to you. There's no definite way you have to make this. It's your own. So there's that. That's my lesson on the layers of the atmosphere. If you have any more questions about it, if you want me to explain something, again, because I know sometimes when I explain it isn't the clearest, you can ask in the chats, and I'll hopefully talk to you soon. I hope you had a good summer here at the Virtual Cadet Training Center, and I'll hopefully talk to you soon. All right, goodbye.